So, example. So in this case, again, we are on nodal analysis without voltage sources. So if you notice, puro na siya mga current source ang available, no? And the current source, if you look at the current source, iba-iba ang directions, no? They have different directions. This current is pointing up, and this current source here is pointing down. Okay? So it says in the steps that was introduced a while ago that you need to identify the nodes in the circuit. So here it is already identified. You have 1, okay, and we have node 2, and we have node 3, and the node 3 is now what we call the reference node. While these two here are what we call the non-reference nodes. Okay? All right. So the next step is to apply KCL. Okay, so apply KCL on the node. No, so before we can apply KCL, then we have to assume currents that are passing through each of the branches in the circuit. Okay, so we now have in this branch, now where the 1 ampere source is found, we know that this current will just go into this node 1. No, but we don't have assumed currents in 6 and 2 ohms. So normally, when we assume currents, since this is a resistor, then we have to consider the flow of the current. Okay, so in a resistor, again, this was introduced to you before, no? The current flows from higher to lower potential. Okay, so higher to lower potential. So expectedly, if this is the non-reference node and this has a zero potential, V is equals to 0, then therefore this node here must have a higher potential, compared to this reference node. So that would be our assumption. So therefore, our current now will be pointing in that direction. Okay, then here we now assume that your current will flow on this direction. Okay, so this one you arbitrarily select the direction of the current. Well, this one, because this has a lower potential, then expectedly this should flow on this direction. But take note that our assumptions here may be wrong. Okay, our assumptions here may be wrong. So later, how do we know that our assumptions are wrong? Now, if later on in the solution we found out that I1 is negative, then therefore the current, the actual current that is flowing in the 2 ohm resistor should be flowing from upward. Okay, the same goes if later we will solve that, we'll be able to determine that I2 is negative, then therefore mali ang direction ating na-assume. So as easy as that. So ganun lang siya. So this one, since this is already also connected to the reference node, then therefore we can assume that the current flows on this direction. Okay, so we now have these currents and name these voltages V1 and V2. Okay, so usually ganun yung ginagawa ko, at V1. Okay, so apply KCL, meaning at node 1, siya ang V1. So KCL daw here is current entering minus current leaving. So that will be 1 is equal to I1 plus I2. Okay? So, again, in the steps, we need to represent each of this current here in terms of voltages by applying Ohm's law. So, if we apply Ohm's law, where Ohm's law is equals to V is equals to I times R, then therefore I is equals to V over R. Okay? So therefore, I1 is equal to the voltage across I1 is V1, okay, divided by resistor R2. Okay? And I2 is equal to, take note that the potential here, the potential across the resistor, is the difference between the node voltage V1 and V2. How do we know asa ang negative na value? Take note again, in a resistor, the current flows from higher to lower potential. So since we assume that the direction of current is in that direction, then V1 should have a higher potential compared to V2. So therefore, the voltage across this resistor is is equal to V1 minus V2. So that is V1 minus V2 divided by the resistance 6 ohms. We substitute these values on the KCL equation. Then 1 is equal to V1 over 2 plus V1 minus V2 over 6. Okay? All right. So applying the LCD, least common denominator. So we know that LCD here is what? 6 atong ibutang, no? Times 6. So multiply 6, no, on all of the here, no, that becomes 6 is equals to 6V1 divided by 2 is 3V1. Okay, 6 divided by 6 is 1, so that becomes plus V1, this is V1, minus V2. Okay? Right? So combining like terms, so 6 is equal to 4V1 minus V2. So this will be our equation 1. Okay? All right. So at node 2, or at
Sir, sir,
V2.
excuse sir.
Yes, yes, yes.
Medyo mabilis sir. Hehe.
At least you can view the video later. Okay? So just go back with the video. So, at node 2, so V2, meron pa isa dito, no? So, you can, it's the same procedure, no, na ginawa natin doon sa V1. Alright? So, at V1, so again, apply KCL, no, at this node. Current entering is equal to the current leaving. So, current entering is I2 is equal to I3 plus 4 amperes. Okay? So, again, I2, express this current, no, as voltages, no, in terms of this Ohm's law. So therefore, I2 is equal to, ano na yun, wala na ako. Again, here, current flows from higher to lower potential. So we know that V1 is at higher potential compared to V2. Okay? So that becomes V1 minus V2 divided by 6. Okay? For I3, that is V2 divided by 7 ohms. Again, substituting here. So we have V1 minus V2 over 6 is equal to V2 over 7 plus 4. Okay? Right. So LCD, so ito i-multiply dire, 42 Tama? 6 times 7 is 42?
Yes, sir.
Okay,
Yes,
so
sir.
multiplying 42 no, to each of this here. So that becomes 7 times V1 minus V2 is equal to 6 V2 plus 4 times 42. Okay? So 7 V1. What is 4 times 42? Minus 7 V2 is equal to 6 V2 plus, can you multiply this 4 times 42? I don't have a calculator. Pilay answer, ana.
168, sir.
168. Okay? So combining like terms, boundary ang 6. So this becomes 7 V1 minus 13 V2 is equal to 168. This is now our equation 2. Okay? Right. So, asa ba ta mag-solve ani? Wala na space for new na mga ano. So, na ko siya i-kopya. 6. Teka lang ha. Magpa sa kong papel. There we go. So, our equations now are 6 minus 4V1 minus V2 and parang may mali dito sa ginawa ko. 7 V1 minus 13 V2 is equal to 168. Okay, so let's erase this. Erase the pen. Alright, so let's write it here. Our equation 1 is 4V1 minus V2 is equals to 6. And equation number 2 is 7V1 minus 13V2 is equals to 168. Okay? Right. Now, actually, there's a shortcut. No? Di ba mahaba masyado yung ating ginawa kanina? So, there's a shortcut on how to do this. No? So, let's just check if we can get the same equation. Okay? So, again, but however, here, we're still going to use V1 and V2. Okay? So, let's check no, kung the same nga ba ito na makuha. At V1. So, when you do that, when you do a shortcut, no, first, you write V1. Okay? And multiply V1 to all of the sum of the inverses of the resistances adjacent to it. So, ang adjacent resistance sa iyaha is 6 and 2. So, inverse of 2 is 1/2 plus inverse of 6 is 1/6. Okay? Then, minus. Minus nimo ang katong mga voltages nga adjacent diri sa imuhang V1 via a single resistor. So kani siya, i-connect niya ang V1 and V2 via 6 ohm resistor. So that becomes V2 over 6. Okay? And then, minus nimo ang mga current sources that are entering no there is a node. In this case, ang kaning 1 ampere na to is entering dito sa node. So that is 1 ampere and that is equal to 0. Okay? So if we apply LCD no to simplify the equation, then we still use this one, no? So 6 asa na ta? So V1 times 6 over 2 is 3 plus 1, no? 6 over 6 is 1 minus 6 over 6 is 1 gyapon. So this is V2 minus 6 is equal to 0. Okay? So combining, simplifying further, this becomes 4V1 minus V2 minus 6 is equals to 0, or 4V1 minus V2 is equal to 6. Notice that this equation is just the same with this equation that we got a while ago. Okay? No? So mas dali siya, di ba? You don't have to go through the equation na mag-KCL pa ka diri. Okay? So it's just a matter of understanding how ang katong mga this is generated. So you may want to go back to the video later to understand kung saan ni siya pag kuha ang kaning equation using the shortcut method. Okay? So again, in the board exam, the shorter time that you answer the question, the more questions that you can answer. Okay? So sa toa pa, abot sa board exam, kinahanglan katong mga techniques and how to shorten the solution should be understood. So diha naman na siya itudlo sa inyo ang katong mga shortcut method. Of course, here in school, di na siya ginatudlo ang katong mga papaspasay o gamit sa calculator. Here, kanilang ang among ginatudlo nga shortcut. Okay? So let's see if we can get the same equation at V2. So at V2. Okay? So kung V2 na gani ka, V2 na po din mong gamiton. So times the adjacent resistors that are connected to V2. So add ang mga inverse, so that becomes 1, 6 plus 1 over 7. Okay? Minus ang katong mga adjacent node voltages connected via a resistor. Okay? So that becomes V1 divided by 6. Ang katumang 6 ang nag-connect sa iya dito. Okay? And in this case, since this is a resistor, which a current source, which is going out of the node, so ganina atong minus ang going into the node. So ang kaning going out of the node, ato ni siyang himuon nga plus, ano ba yan? Plus 4 is equal to 0. Okay? So again, applying LCD, so 42. Okay? So V2 times is 7 plus 6 minus 7 V1 plus 168, right? 168 is equals to 0. Okay? So this becomes 13 V2 minus 7 V1 plus 168 is equal to 0. Okay? So, yung mga tuingan nga form, so that becomes 7V1 minus 13V2 is equals to 168. So, which is just the same with this equation here. Okay? Alright? So mas dali siya, no? Mas dali siya himuon no, using the shortcut method. Okay, now take note, no, there is electric circuit analysis. No, we do not teach you math anymore. Okay? We teach you ang katong mga steps ganina. No, ang katong math, it is given na kabalo na mo no saan pag-apply sa mathematics, paggamit sa mathematics diri sa atong circuit analysis. Nevertheless, using the same equation, di ba? Linear equation man na siya, so pwede na to siya himuon into matrices and determinants. Okay? So that becomes 4 minus 1 times V1 is equal to 6. Okay? And this becomes 7 minus 13 is equal to 168. Okay? So from this point on, Kramer's rule lang ang gamiton. No? We're not going to use substitution. No? Pang high school na siya. Pang senior high. Okay? So I suppose kasabot na mo sa paggamit sa sa Kramer's rule. Okay? So, di ba? To solve for V1, that is equal to delta V1 over delta. While V2 is equals to delta V2 over delta. Where kaning delta nimo is your determinant and delta V1 is somehow a determinant. However, substituting these values here for the first row here, and for delta V2 substituting these values to the second row and getting the determinant. Okay? So, kamo na bahala mag-solve ana. Gusto nangita ka na nangutana ganyan nga paspas ra. So, ana gina siya. Okay, and take note ang EEE 130 is already up to AC analysis na siya. Okay? Unlike in the previous curriculum, we assign DC analysis to EE 131 and then AC analysis to EE 132. So dire combine na ang EE 131 and 132, and then we have EEE 132 is nag-higher na siya nga circuit analysis. Okay? So, if you have your textbook, ang katong electric circuit fundamentals of electric circuit analysis by Sadiku, you can look at the appendix in order for you to review ang katong Kramer's rule.